In this next session, we're going to look at lessons 57 through 59. In lesson 57, we're going to look at sinusoids, and what we're going to be looking at are periods and phase shifts. We're adding those to what we have been doing. Now, you'll need your book and look at 57.1, that example, on page 376. And in that one, it says, write the equation of the sinusoid shown here as a sine curve with a phase angle, and also as a cosine curve with a phase angle. So I'll go ahead and attempt to draw this one. Something like this. Got the line going through there, and it's about right there is the y-axis, and this is theta. So right here we have 30 degrees. It crosses at 120 degrees, crosses again at 300 degrees. It's down here at negative 60 degrees there. Let's see, a 210 somewhere right here. 360 is about right there. Now, what they want you to do is write this as a sine and a cosine function. This is the new thing, and this is called phase shift. And we'll get into the next thing, period, here in a second. But on phase shift, first of all, I didn't do the up and down the center line. You have the height is 2, the trough is negative 2. So you have 2 and negative 2. Well, that's easy because that puts the center line. Oh, that's a lie. I was looking at a different one. 6 and 2. Okay, so this one's at 6 and positive 2. 6 and 2. So that puts the center line at 4. So y equals 4, and we're going to make these positive sine and cosine deals. So it's y equals 4. It's going to be a positive sine function. Y equals 4 plus 2 is our range sine. And what we're going to do is it's a theta, put a parentheses, this is the new part. And this is going to be a sine function. This part on the way up needs to be there. So we're going to add 60 degrees. If we add 60 degrees, it would phase shift it over to where it's a positive sine function going through the origin on the way up. That's where we made it a positive. We made it a positive sine function. Okay, so this is the new part. So you can shift it over 60 degrees. Okay, let's phase shift the cosine function. Everything's going to be the same, except for it's going to be cosine, and a cosine, we would need to back this part up. And so in order for this to be a cosine, it looks like that is right at 30. So we would need to back this one up 30 degrees. So that's there. Back it up 30 degrees, and you would have a positive. It would be right above there. The cosine would be right above there. It would be a positive cosine function. So that's how you do phase shift. This next concept is period. Still has to do with sinusoids. And we'll call this one a sine function. So y equals, because it's a positive on the way up right there. Y equals 10. It's a positive 10 is the center line. It's going to be a positive sine function. So plus 2 is the range from 10 to 12. Sine. And it is a theta. Didn't put that on there as a theta. And now, there is no phase shift. It's all good. It's going straight for the origin like it needs to. Don't need to move anything. But period is a circle, okay? So from here to here is a circle. If we flipped that, it would make one circle. So what is it, one full period? Well, this is at 0 degrees, and one full period actually ends at 90. Now what it's always been, you didn't realize it, we didn't look at it, but it was always from 0 to 360 in one period. But in this particular case, it's from 0 to 90 is one circle, one rotation here is 0 to 90 degrees. Well, you're going to do that 4 times to get to 360. So 4 theta is the period. Now, if it was 0 here and 360 here, then it would be just 1 theta. It'd be just a normal rotation. But because it's just to 90, you're going to have to multiply it times 40 to 360. So this would be your answer of period on these. In the first part of lesson 58, they want to know the distance between a point and a line. In order to do that, you're going to do 3 things. You're going to get the perpendicular line to this line. Then you're going to solve for x and y. Then you're going to use your new x and y, and then your original x and y, put it in distance form of your calculator, and find the answer to get the distance in between these two. First thing we're going to do is get a perpendicular line, which we know a perpendicular line is the negative reciprocal to that. Then plug in this to find your b. So you get 5 equals negative 2 times negative 3 plus b. So you get positive 6, bring it over to negative 6. So negative 1 equals b. So negative 1, that is the perpendicular line to that line. Now you will use these lines, and you can, in order to solve for x and y, you can use, put this in your calculator and use system of equations, so it's real easy for you guys. When you do that, I won't take time to do that for y'all, because you know how to do that. Whenever that happens, you're going to get negative 4/5 and 3/5. Or you could put it as decimals, doesn't matter. Then you're going to use the distance formula in your calculator. Put these 2 points in for the distance formula. When you do that, you'll get 4. The distance is 4.92. Last thing we're going to look at is logarithms in lesson 59. And this one, they call it the White House is white, because that's like a redundant thing to say. And when you have 42 log 42, you can actually cancel it. And your answer is just that 5. It's just 5. In this one, it's a little tougher to see. And so you're going to go, instead of 9, write it as 3 squared. 3 squared log 3, 5. Bring the 2 and put it up here. And then the White House is white, and you get 25 for your answer. Right here, you're going to bring them together first. So it's log 3, 4 times 5, which is 20. The White House is white, and 20 is your answer. So this is actually a pretty easy type of problem to do.